Hello future engineers and my dear students, welcome back to Mudassir Academy. In today's video, we are kicking off with a brand new module in Engineering Mathematics 2 for the VTU and Autonomous Colleges syllabus. Today we are going to study or start with a topic called vector calculus. Now this vector calculus can be divided into two parts. One is a vector differentiation, another is a vector integration. The vector differentiation is considered to be easy and scoring as per the examination point of view and the syllabus pattern. Now, before starting this vector differentiation, we will be studying some basic theory and important formula which you need to memorize. Without this, you cannot solve the problems of vector differentiation. See, I am going to make those stuff, the theory and the formula very easy for you on the board, but since retention is the key, I need you to write down 3 to 4 times and practice them perfectly so that you score good in the examination. So, grab your notebooks, your pen and let us dwell into the world of vector calculus. But before starting, if you are new to this channel, then please subscribe and hit the bell icon to stay updated for the further videos or further series on vector calculus. So, as you all know, a vector is something which has a magnitude and a direction, and a scalar is something which has only magnitude and no direction. And since I will be writing here the formulas for vector differentiation, we will be dealing with vectors only. After doing vectors, I will write the formula for scalar functions. Okay. Now, as you all know, in space, the position vector is given as r vector is equal to xi plus yj plus zk. Fine. Now, if x, y, z are functions of say t, then we can write this as r vector is equal to x of ti plus y of tj plus z as a function of t. For this, the velocity is given as v vector is equal to dr by dt, differentiation of r with respect to t. Now, this velocity is also called as the tangent t vector. Okay. See, velocity is given by v is equal to dr by dt. So, the acceleration is given as acceleration a vector is equal to d square r by dt square. This is basic stuff. Okay. Now, here you need to remember a very important differential operator called as del or nabla. It is very important to remember this because we will be using this operator to solving 90% of the problems here. Okay. Now, this operator is right here, the differential operator is given as del or nabla. So, we write it like this, del is equal to del, see inverse delta, that is given as dou by dou x of I plus dou by dou I of j plus dou by dou z of k. Very important to remember. So, what is del? Del is dou by dou x of I plus dou by dou I of j plus dou by dou z of k. But you need to memorize this. Next, after del, say if I have a vector function, say, so I take a vector function a vector is equal to a1i plus a2j plus say a3k. Okay. Now, for this vector function, for the vector we have something called as divergence or the dot product. So, we have the divergence given as divergence of a vector is nothing but del of a. See, the del is used here, del of a. Now, what is del? Del is dou by dou x of I plus dou by dou y of j plus dou by dou z of k into a1i plus a2j plus a3k. Now here a very important point. See, always in this vectors, what happens is, see, I into I is 1, j into j is 1 and k into k is 1. Okay, I write down here best. I into I is 1, so we can write here I into I is equal to 1, j into j is equal to 1, also k into k is equal to 1. So enough. Now what happens, I goes to I, that means I multiplies by I dot product to become 1, j multiplied by j becomes 1 and k goes to k to become 1 always. Okay, whereas I into j, j into k, everything will be 0. So we are not bothered with it. Only where is there is I will always go to I to become 1. J will go to j to become 1 and k will go to k to become 1. So the divergence of this is written as what? So di of A vector is equal to how much now? See, I goes to I is equal to I into I is 1, j into j, k into k is 1. So this will become dou A1 by dou x plus dou A2 by dou y plus dou A3 by dou z. That's it. So the divergence of the vector is dou A1 by x plus dou A2 by y plus dou A3 by z. That's it. Now the next concept is called as very important concept called curl. So they will be asking a question here for on this curl for 6 to 7 marks. Okay, so we solve it later. So first the curl. So the curl of A is given as curl of A is nothing but curl is a cross product. Now the curl of A is given as determinant I j k dou by dou x, dou by dou y, dou by dou z, and what is A vector? A vector is A1i plus A2j plus A3k, right? So write those things here, A1, A2, A3. That's all. This is a curl, and curl is a cross product. That is del cross of A is equal to this much. Divergence is dot del into A, and curl is cross del cross A. Okay. So now we have seen the formulas for divergence and for curl, right? Now the theory says if divergence of A equals to 0, if divergence of A equals to 0, we call it what? Solenoidal vector. We call it a solenoidal vector field. Okay, alright, solenoidal vector field. What is the condition? Divergence of A 0 means it's a solenoidal vector field. But if curl of A is equal to 0, curl of A equal to 0, then we call it very important. If curl is 0, we call it irrotational. Irrotational vector field. Irrotational vector field, or we also call it conservative field, and also potential field. So this all. So what is that? Again, if divergence is 0, it's solenoidal. If curl of A is 0, then it's irrotational, conservative, or a potential field. Now here phi is called as, see, sometimes we call it flux also. Okay, so we can write phi is also called as the scalar potential. Okay, or the flux. Now this scalar potential phi can be found from this. That's why the question comes together for 6 to 7 marks. Now to find phi, to find the scalar potential phi, use the formula, very important formula, del phi equal to F vector. That's so del phi is equal to F vector. So as A vector, F is a vector, or it can be del phi is equal to A vector also. So these are all the formulas for solving problems on vector differentiation. So again I tell you, I have written in a very simple way, write down 3 to 4 times and memorize. So now we are moving ahead with formulas on scalar functions. Now the next is surfaces or scalars. So if you have the surface, say phi of x, y, z equal to c is a surface. This is what? A scalar surface. Now for this surface, the vector normal to the surface, what is that? The vector normal to the surface phi is nothing but del of phi. Del is a differential operator nabla. Del phi. What is del? Del is again dou by dou x of I plus dou by dou y of j plus dou by dou z of k into phi. Now here this phi multiplies by each and every thing. So that is, we have del phi. Del phi here, see, we discussed our vector, we had divergence dot product. That is divergence of the vector point A, that is del of E. Same thing, surface we have gradient. The del phi is also called as gradient of phi or gradient of phi or grad of phi. Okay, that is nothing but del phi. Fine. That is, we can write del phi is equal to, take phi inside, dou phi by dou x of I plus dou phi by dou y of j plus dou phi by dou z of k. That's it. This is what? Del phi. Now, unit normal along del phi. So we have vector normal to the surface is del phi. Okay. Now, unit vector, best formula is unit vector normal, unit vector normal along this del phi is given as n cap is equal to del phi by modulus of del phi. Now this modulus and all will discuss in while solving the problems. So what is the unit normal given by? N cap is equal to del phi by modulus of del phi. Okay. Now the very important formula of which they ask, one question will might be asked in the examination is angle between two surfaces. See, angle between two surfaces is also called as, we also call it as two is, one is angle between two surfaces and also called as angle between normals. See, both are same. Angle between the two surfaces and angle between normals both are same. So that formula is given as cos theta is equal to, see, one surface normal del phi 1, other surface say del phi 2, phi 1 and phi 2 are two surfaces upon modulus of del phi 1 into modulus of del phi 2. That's all. So the angle between two surfaces is given as cos theta is equal to del phi 1 into del phi 2 upon modulus of del phi 1 into del phi 2. 6 marks question. Now, if theta is equal to pi by 2, means what? 90 degrees, correct. So, the surface is very important point, intersect 90 degrees is what? There is a there is a definition for it. If theta is equal to 90 degrees, surfaces intersect orthogonally or perpendicularly. So, we write it as orthogonally. The surfaces intersect orthogonally. That means cos of pi by 2 is equal to 0, because cos 90 is what? 0. So, we have, when you put cos 90 0 here, so the condition for orthogonality becomes what? 0 is equal to del phi 1 into del phi 2 by modulus del phi 1 into del phi 2. That is, the condition becomes del phi 1 into del phi 2 equals 0. This is the simple condition. Okay. So, this is the condition for orthogonality of two surfaces. The next very important concept is called directional derivative, which they ask question. Okay, that is called what? Directional derivative. Directional derivative of the surface phi x y z along a direction d vector is directional derivative of surface phi along a direction d vector is given as del phi into d vector whole divided by modulus of d vector. One more important formula, directional derivative. What is it? Directional derivative along direction d vector is del phi into d vector divided by modulus of d vector. Now, I will write short form directional derivative dd. So, dd, directional derivative is maximum along del phi. So, directional derivative is what? Maximum along, when they ask maximum what is the directional derivative, it is nothing but del phi, that is it. The next is, if phi of x, y, z is temperature function, is a temperature function, okay, then the directional derivative dd of phi along d vector is the rate of change of temperature. A useful theory here to solve the problems. Okay, then the last here is, so we learned about direction derivative is maximum along del phi, and phi x y z is a temperature function, then direction derivative of phi along d vector is the rate of change of temperature. Now, maximum magnitude, one more point here, maximum magnitude so this theory also will be useful in solving problems. So, I am writing down each and everything here for you to understand the concepts correctly and to attempt the questions. So, maximum magnitude of directional derivative of phi parallel to what? Parallel to x axis is del phi into I. What is that? Maximum magnitude of directional derivative of phi parallel to x axis is del phi into I. Similarly, maximum parallel to x, parallel to, right here, parallel to y-axis is del phi into j, and lastly parallel to z-axis is del phi into k. Okay, so now these are all the theory and the important formula required to solve problems in both vectors and surfaces. So again I request you to please write down all this 3 to 4 times in your notebook and memorize them. Otherwise, you won't be able to solve the problems here. Okay. So that's all for today. So in today's class, we have overviewed the basic theory and the formulas required for both vectors and surfaces. If you memorize this, write it down, 3 to 4 times and memorize this perfectly, then you can easily score good marks in vector differentiation. Okay. So problems I don't want to do in today's class, so that will keep for the next video. I want to give you some time to memorize this thing and then come back. Okay, so that's all for today. If you have any doubts or queries or any suggestions or any questions, then please drop a comment below. Share these videos with your friends, refer them, like them as much as possible. Okay, and also if you haven't subscribed, please hit the subscribe button to keep me going, push me going to make such videos for you. So that's all for today. Thanks for watching. See you in the next video. Till then, bye.